Hey guys, Mr. Backer here. In this video, we're going to look at odd and even identities. Now, as we're talking about our even and odd identities, we want to remember what it means to be odd or even. So if we want to remind ourselves, we're going to think about this graphically. And to be an odd function, what that means is that a graph has origin symmetry. And kind of a classic example of an odd function is a cubic graph, where if we take what's in the first quadrant and rotate it around the origin, then that portion of the graph will meet up with what's happening in the bottom left third quadrant. And in order for a function to be even functions have y-axis symmetry. So a kind of classic example in there is an x squared graph, a parabola. Because what's happening is if we take the stuff that's happening in the first quadrant and fold it over the y-axis, then it's going to meet up with what's happening in the second quadrant. Now we can also think about our trig functions as being odd or even. And if we're thinking about a sine graph, kind of the general sine graph starts at the origin, goes up, and then comes back down. But if we were to extend that in the negative direction, my graph would go down and then come back up. So what's happening in here is we're taking the portion of our graph on the right-hand side and we're rotating it around the origin, and all of those points would match up. So a sine function is an odd function. If we think about a tangent graphs have asymptotes on either side. And they look almost sort of like a cubic graph where it starts at the middle and goes up to the right and then it goes down to the left. So this one is also going to have origin symmetry, making it odd. But a cosine graphs typically start up at the maximum, go down, and then come back up. And if we extend that left into the negative direction, we would go down and come back up. So this graph has y-axis symmetry, making it even. So now as we're talking about these odd and even identities, we're first going to talk about our odd functions. And one of the odd functions we said was the sine. And what's going to happen, because sine is an odd function, if we wanted to look at the sine of a negative theta angle, then because this function is odd, what we're actually allowed to do with this is we can pull that negative out in the front and think about it as the opposite of the sine of theta. Now, because sine is odd, its reciprocal is also going to be odd. So if we look at the cosecant of negative theta, then what we're allowed to do is pull that negative out in front and get the opposite of the cosecant of theta. Now, tangent is also an odd function, so the tangent of negative theta is going to equal the opposite of the tangent of theta. And because the tangent is odd, then its reciprocal is also going to be odd. So the cotangent of negative theta is going to equal the negative cotangent of theta. Now, as far as our even functions, we talked about the cosine as being even. And what's going to happen in there, if we look at the cosine of negative theta, because cosine is even, then the negative on the theta really isn't important at all. We're going to get the same exact answer as if we just did the cosine of theta. And because cosine is even, then its reciprocal is also even. So the secant of negative theta is going to be equal to just the secant of theta. So just like we did with the cosine, we can kind of ignore that negative on that theta angle. So in this example, we're going to get a little practice using some of our identities. So if we know that the cosine of theta is equal to 0.34, then what we want to find is the sine of theta minus pi over 2. Now, as I look at the sine of theta minus pi over 2, that looks really close to one of my cofunction identities, but the stuff inside of parentheses is reversed. So what I'm going to do with that is I can take that sine and I'm going to take the stuff inside of parentheses, but I'm going to factor out a negative. Then what's going to happen is that positive theta is going to turn into a negative theta, and that minus pi over 2 is going to turn into a plus pi over 2. But I'm going to take what's on the innermost set of parentheses and I'm going to flip it around. So this is going to say the sine of the opposite of pi over 2 minus theta, because now that looks a little bit more like one of our cofunction identities. Now I see this negative that I just factored out of that stuff on the very inside. We just talked about sine being an odd function. So if I have the opposite of a specific angle, then what I'm allowed to do is take that negative and pull it out in front of the sine. So this is going to become the opposite of the sine of pi over 2 minus theta. Now, as I'm looking at this sine of pi over 2 minus theta, that is one of my cofunction identities. And I can take the sine of pi over 2 minus theta and turn that into a cosine. But I can't forget about the negative that we just pulled out in front. So this is really going to turn into negative cosine of theta. But earlier on we said that the cosine of theta was 0.34. So if this is going to be negative cosine of theta, then my final answer is going to be negative 0.34. That's going to be it for this video. Thanks for watching.